Okay, hi everyone. Okay, I see some people. Put a plus if you can see me and you can hear me in the chat box. And probably write what country you're from. Okay, I can see that you can hear me and you can see me. Hi. Okay, hi Armando, hi Sergey, hi Rod from Canada. Amazing. So good morning there. And Vera from Ukraine and USA, Denver, amazing. Argentina, right. Okay, good day there in Argentina, good morning in Canada, good morning in the USA, and good evening in Europe, I probably think so. Okay, cool, amazing. So let's start. So today we're going to talk about fighting soil degradation, and we'll talk about EOSDA solution in particular for that, like what we do to tackle these challenges. So before we start, I want you to remind that we'll tackle all your questions after the webinar. So please place them in the chat box, or if you want to speak to us privately for some reason, I don't know why, but you're welcome. You're most welcome. Email us at sales@eosda.com. Right. Also, I remind you that we'll send the presentation and the recording of this webinar afterwards. So no worries. You can watch it anytime at your availability. Right. So who's today going to be speaking? So this is Vasyl Cherlinka, our scientist that is particular working all this time, who's devotedly been working on the background, on the back end of all our developments related to soil modeling and mapping. So he'll cover the scientific perspective of this question, like the causes of soil degradation, what we can do with that. I am Lina. I am head of customer success here at EOS Data Analytics, and I am taking care of our customers. I am pretty much aware of all their challenges and goals and the way we can solve them. So I'll cover some cases with our customers that are related to soil degradation or soil modeling and mapping, and tell you more how we handle those cases. So today we'll talk about soil mapping, soil modeling. I'll show you what kind of cases we work on. Vasyl gonna cover the scientific perspective of this question, and then we'll talk about the power of our EOS solution, our satellite that we just recently, 2 weeks ago, launched into the sun synchronized orbit. So for those who's joining us the very first time and know nothing about our company, let me just remind you or tell you. So we are EOS Data Analytics is a part of Space Venture Holding. We're an American company with Ukrainian roots, so our founder is actually Ukrainian. Our team is around 200 employees, and it includes research and development team, science, products, sales, marketing, pretty much everything. And this is something that makes us independent in terms of having an idea and delivering to the market whenever we want it. So you can see some of our customers. Yeah, so what we are actually doing, so we have developed so far 3 products that are working out of box. First of them is crop monitoring, that solution, out of box solution that provides you with satellite imagery analytics and weather data analytics and subtabs for farming management for farmers and food suppliers, food producers, where you can find useful information about the health of your crops and the state of your crops and make it actionable. We provide custom solutions in this regard, customers sometimes are interested in crop classification, harvest monitoring, yield forecasting modeling, soil moisture analytics. This is something that we provide on demand. And actually, we are working to make it out of box. If talking about crop yield model and forecast, we're really exciting. Probably this quarter, we'll launch add-on additional functionality that will be forecasting your yield. So we are working to make it all the services out of box. Land Viewer, this is another our development that provides you with out-of-box analytics for satellite imagery of different providers, not only like non-commercial ones like Sentinel or Landsat, but you can find Geosat there, Geofan, and other satellites. Forest monitoring is our youngest child. It's been like a year we released it, and it's showing you the forest cover and changes within the forest cover, like the harvesting that happened within this area for the specific period of time. So you're most welcome to check on these solutions if you find them interesting. Okay, so let's move to the topic itself. And yeah, don't forget to put your questions in the chat box. Okay, so soil degradation. Before we start, let me give you a little bit of background, like why we're talking about this today and why we are bringing up this topic. So some numbers, some figures, facts, so you can understand at what stage of the problem evolution we are at the moment. So with the so-called Green Revolution that was happening back then, like between World War II and till the 80s. So Green Revolution, it's like when farmers started using the land intensively. I mean, applying seed hybrids, fertilizers, machinery, techniques, and like different techniques. This is something that helped to increase the productivity of the main agricultural crops in 2 times. And for example, the yield of some cereals like maize and wheat, they managed to increase it by 4 or 5 times. So it actually means that from 1 hectare of land, they started getting like 4 or 5 times more tons of wheat or maize. And this is something that helped the world to meet the food demand and save millions of people from starvation. Asia, for example, which was threatened by hunger back then in the 60s, became self-sufficient in foods within like 20 years, even though its like population growth, like it actually doubled. And the question is like how it happened, right? So but 70% is due to the intensification of agriculture, like new varieties, fertilizer, irrigation, use of inputs. And the remaining 30% is a result of new land being brought into production. At the moment, agricultural land is occupying 40% of the land surface. Over the last 50 years, the world's cultivated area has grown by 12%, mostly at the expense of forests, wetlands, and grasslands. And the irrigated area actually has doubled. I know that you are probably going through all the text that is given on the slide, so we'll give you like, 10 seconds so you can read it, so you can listen to me. But anyway, so as a result, global food production during the past decades has been experienced like massive increase in the use of inputs such as nitrogen, phosphorus, pesticide application, and of course extensivity of irrigation, use of irrigation and air energy. And this intensification of agriculture has also led to the degradation and exhaustion of soil and land. And that's why actually we are here today. And due to the increase in consumptions, which is logical to the population growth, it's been estimated that the global yield production would need to increase but 70 or 110% to meet the food demand by 2050. And every year, we need to increase yield of cereals by 1 or 1.5%. In case we want to meet this projected demand by 2025. And another thing that, for example, yes, let me switch to the next slide. Okay, yeah, here we go. And for example, according to FAO researchers recent, the arable land in developing countries will have to increase almost by 13%. It's like 120 million hectares till 2030. So it means that 120 million hectares will be cropped by 2030. And just for your understanding, it's like having 2 Frances completely cultivated. And those 2 Frances will be serving us, like, to feed us by 2030. So we'll be involving more and more land into agricultural activities, which means we'll be exhausting them eventually. And the thing to mention here, like, soil degradation has become a very serious problem in densely inhabited agricultural regions. For example, India supports 18% of the world's human population, like supports with the food, right? And 15 of the world's livestock population. But India has only 2.4% of the world's land area. So you can imagine how intensive their agricultural activities is and how exhausted the soil might be in the future or already is. And you understand that soil degradation is causing a decline in crop productivity and huge economic loss, putting the food security and livelihood of farmers at risk. And this resource is not renewable. FAO says that about 25% of land will be eventually like degraded, and yeah, so and estimates of soil degradation like this, they highly vary. So different scientists give different numbers, but we do understand that this is something that is not renewable, and if you put something in it, you'll get an effect. So even though like soil degradation is pretty controversial topic, because some scientists, they say that we still have some land to be cropped. Other scientists say no, it's like pretty exhausted. We can extend our lands using like forest areas. That was happening like in the 90s, right? But this land is not really good like for crop production. But what we know at EOS Data Analytics, we completely understand that we cannot, stop the harmful process. We're just humans after all. And at EOSDA, we are sure about our role in this argument. We'll be continuing producing solutions to decrease the consequences of soil degradation through promoting sustainable farm management and giving instruments for farmers and food production companies to actually measure this impact and make decisions based on this. Because if you can manage, right, you can rule, you can manage. Like if you can measure, you can manage. And we'll continue. So let me just give you the overall idea what kind of things we're involved in at the moment. Okay, let me know if you see my slides, right? Because I experienced some difficulties here in the chat. Can you see my slides, right? Yeah, amazing. Good. So what are we doing here at EOSDA to make it happen, to provide you with the instruments to measure it or promoting those activities, more sustainable farming activities? So we'll continue to develop a scalable model to assess soil organic carbon and help our partners encourage farmers to switch to more ecological farming practices. We'll talk about this later. We'll definitely continue developing products and tools to measure impact of climate change conditions, to model and predict yield forecast under considering the current management techniques. We provide recommendations on fertilizer application or crop rotations to reach the maximum possible yield. And we'll continue developing tools and models to assess and predict the quality of soil to ensure better yields and access the full potential of the field, like knowing without very intense and harmful practices, even though pretty all practices are intensive and harmful. So moving forward to the cases, to the real cases that we have. So let me give you the basic idea we're currently involved in. The most exciting project, I would say, for the next year and this year that we have is our cooperation with AgriProve. Together with them, we're developing a model for measuring soil organic carbon using the remote sensing technology. So the main goal is like to lower the costs of accurate soil carbon measurement, because this is the most expensive part for a farmer to afford. And AgriProve is actually an Australian company and is a leading soil carbon developer. And they have 80% of successful rate of implementation carbon projects in Australia. And so why we decided actually to give it a go, why we are decided to be involved in this project. So actually, okay, I'm here. So 45%, like forestry and land use, is responsible for 45% of greenhouse gas emission into the atmosphere. And the government, in order to regulate and to reduce this greenhouse gas emission, they developed the carbon credits. Carbon credit is a kind of a pyramid that represents 1 ton of carbon dioxide removed from the atmosphere. So, and some companies and producers can buy it. So actually here, okay, let me see. Yeah. It costs like from 0.6 to $100. It depends on the country and the industry and you are involved in. And actually, you can see the countries, the largest carbon emitting countries, and some companies that actually buying those carbon permits, carbon credits. And how it actually works, let me show you. So it means that those big companies that invest in carbon credits, and those money afterwards, they will be invested into the efficient farming techniques or something to like industries that can build these carbon credit offsets actually. So for example, I mean, if you're a farmer, you can get money if you follow like some farm management techniques like livestock feed activities, practicing rotation, grazing to sequester carbon in the soil. And for example, you select high quality feed that will reduce methane released like from the fermentation, or you like using tillage, you practice coverage. And for example, just to give you a good example, if you are a farm with 1,000 hectare wheat farm, and this farm sequestrating around 3 tons per hectare per year, and it's going to be it's making like 3,000 carbon credits a year. So if some big company that emitting this carbon into the atmosphere will pay you $20 per 1 carbon credit, it means that you will get $60,000 if you can prove that you kind of reserving the carbon inside the soil. So as I already mentioned, you need to be a farmer who is practicing non-tillage, or you reduce tillage, or you use cover crops, or you use proper crop rotation that store CO2 inside the soil and create this carbon offsets. And what we do together with AgriProve, we're building this model that considers weather data, vegetation indices data, like soil data that is provided by our partner. This is soil sampling data. This is the most expensive and most time and resource consuming step, because every farmer, and they want to enter this program, they need to do soil sampling beforehand. And how do they get this credit? So there are 5 steps you need to follow. First, you need to register. Then you need to execute soil sampling at your property to prove the state of your soil before starting implementing proper farm management techniques. Then you implement the farming management strategy in order to follow. And then you need to measure how your productivity, the productivity of the field has changed due to new technique that you have implemented. And after that, if you prove that your farm management strategy is efficient and you actually store and create this carbon offset in your soil, you can get a payout. So EOS Data Analytics is involved in step 2 and step 5. 2, we're trying to build this model in order to measure what's happening with the soil before and after. And also we are proving that something has changed in the field productivity. So here is an example of NDVI trend. This is the easiest way to do this. This is the 5-year trend. And knowing when the farmer implemented strategy, different farm management strategy, we can tell what has changed in the productivity of the field, and that's how we can prove it. So this is our one project. We're still working on this. We're still developing this measurement model. So like follow us to see how it's going to end. Another case that we have with Agrinova Group. This is our partner from Eastern Europe that work in Poland, Slovakia, and Ukraine. They work as a consulting management company together with farm agronomists. They provide baseline information about crops, field location, and boundaries. And they identify areas that require nutrients. So they are actually using our zoning feature in order to divide field into different zones, less and more productive, and create variable rate application maps. And they use like as an advisory service for their farmers. And actually, since they started using it in 2021, they already have some improvements. So they improved the nitrogen fertilization process and optimized clients' fertilizer application between 50 and 130 kilogram per hectare. And also they reduced the need for conventional fertilizers products like granular fertilizers. And like by using this remote farm management technique, they managed to save cost on road shows, like to the field for scouting and checking their field. So they can do it remotely, and only in some critical cases they go to the field. And the last but not the least, this is our future development, which we have in plans for this and the next year, because this is not something that you do like just in several months. We call it exhausted soil model. Our scientists, together with Vasyl, who's going to present after me, we're building like a model that will forecast the state of the soil in several years by taking into account current farm management techniques. And based on that, we can tell you like how productive or non-productive or how exhausted your soil is going to be in several years. And we'll provide recommendation of what could be done to improve soil fertility in the future. So we'll use different parameters. We'll be working together with some of our customers, partners, like who can support us with ground truth data in order to develop. So this is pretty to give you the overall background, what kind of projects related to soil modeling and mapping we're involved in. If you are interested in any of them or like have thoughts or questions, put them in the chat box. I'm reminding you that we're going to send you the recording and the presentation afterwards. So Vasyl, I think this is your turn. I'm passing on the floor to my colleague. He will cover the scientific perspective of soil degradation.
Thank you, Lina. Good morning, ladies and gentlemen. My name is Vasyl Cherlinka. I am a soil scientist, and I'd like to discuss soil science's role in addressing soil degradation. Let me present information on the types, causes, and factors of soil degradation. We will also consider modeling, mapping, and monitoring methods for this phenomena and outline potential ways to minimize them. Now, we will focus on the role of soil science in determining and combating the natural and anthropogenic causes of soil degradation. I would begin emphasizing that, in my opinion, soil is the most valuable national asset in any country and should be protected in all states. In some countries, such as Ukraine, it is even written into the primary law, the Constitution of Ukraine. Why it is so? First, the concepts of land and soil, which are often used interchangeably, should be separated. And really, they are not equivalent. Land is a primary and economic category and is regarded as a resource. And the soil is a unique natural body, the upper layer of the Earth's crust. Soil is formed due to the interaction of vegetation, fauna, and microorganisms with parent rock under certain climate condition over millennia and sometimes millions of years. Fertility is the primary feature that distinguishes soil from rock. In a metaphorical sense, the soil is the Earth's skin, also known as geoderm. Improper use can destroy soil in some decades or even years. Deterioration of soil quality directly affects economic indicators, which is why it is always necessary to keep this in mind. Soils serve a variety of functions in nature. We present two of the numerous classifications of soil functions. As we can see, their scope is extremely broad. Because these functions are global, adherence to sustainable soil management must also be global. Otherwise, there is a risk of causing a global ecological disaster. So, which lands or soil can be considered degraded? I would classify degradation into two broad categories. To the first category, we can add disruptions caused by natural and industrial anthropogenic processes. The second large group is primarily agro-degradations, which are caused by poor agriculture management. Please forgive me, but I have to say about the barbaric methods of destruction soil that the Russian Federation is currently employing in Ukraine, a country known for its soils and agricultural production. In the diagrams presented to you, I introduced a tiny part of the direct physical and chemical effects of military operation on the soil. I want to believe that it will end soon and will never happen again. If we abstract from the previous strict classification and apply classical views, all types of degradation are divided into 4 main groups. We will review them on the next slides. Each type of degradation has distinct characteristics and a more detailed classification. The main pathologies of the soil profile and genetic horizons, for example, include various manifestations of water and wind erosion. Regardless of the definition, water erosion is a hazardous phenomenon that can destroy the soil if landowners and land users do not monitor and fight it. This type of degradation is possibly the most common in the world. In essence, it is pretty simple and consists of 3 processes: detachment, transportation, and deposition of soil mass. The good news is that water erosion can be greatly slowed or completely terminated. What factors contribute to water soil erosion? First and foremost, these are natural factors listed on this slide. Numerous socioeconomic factors can amplify the impact of natural factors. Soil cultivation technologies, for example, fall into this category. Under equal conditions, traditional arable farming will cause more erosion than minimal tillage technologies. All of this causes water to flow down the slope along the open surface of the soil. Sheet erosion gradually transforms into real erosion, the final stage of which is gully erosion. Deposition of soil material also carries risk. The newly formed thick layer of deposited soil is structureless. The soil becomes poorly permeable to water, and the plants under it often die. Frequently, the rate of development and extent of soil erosion are impressive. When the upper layer of soil is gradually washed away millimeter by millimeter by normal erosion, the loss of the upper layer of soil occurs over tens of years. Accelerated erosion, on the other hand, can destroy large areas and render them unfit for agricultural use very quickly. In tropical areas where intensive deforestation is practiced, soil can be completely lost during a single high-intensity heavy rain. So, the consequences of accelerated erosion include the destruction of the fertile soil layer. Also, erosion is harmful not only to soil, but also to all ecosystems related to soils. Hidden erosion is usually visible on the hills, which are lightened due to the lack of organic matter. This is especially visible on satellite images, both on the ground without vegetation and various vegetation indexes. Where soil productivity is lost, these indices significantly deteriorate. Water erosion of soil can be successfully fought, but it requires implementing several organizational, economic, agro-technical, and forest improvement measures. Now I will only state that these measures are highly effective. USDA currently develops tools based on satellite monitoring and mathematical modeling of erosion, which cross-verify each other. There will be an advisory block that will give recommendations for combating erosion based on the result of the analysis. Wind erosion is the next most dangerous type of soil degradation. Strong winds cause the soil destruction process, which typically occurs in the steppe, semi-desert, and desert regions. Why it is happening? See video, please. The truth is that if our soil is not covered with vegetation and plant root systems do not bind the surface layer of the soil, the upper layer begins to blow away in strong winds. The wind erosion process can grow to a catastrophic scale, especially during droughts. It is known as a dust storm, black storm, or black blizzard. The Dust Bowl in 1930 is a well-known example from American history. We have similar cases in Ukraine, where Ukrainian Chernozems was deposited thousands of kilometers away in Sweden. Wind erosion of soil also can be successfully fought. A wide range of improvement measures is available to help with this. Their goal is to leave as many plant residues as possible, with root systems that bind the soil surface and form a windbreak system. All of this allows us to protect the soil from wind erosion. The following degradation types, which we will examine, are caused by human activity. A clear example of agrophysical degradation of soil is compaction. Each soil has an optimal density, with various greatly depending on the clay-sand ratio and the amount of organic matter. However, when heavy agricultural machinery processes the soil in multiple passes, it acts like a press. This result is in a sharp decline in agricultural crop growth and development, because crops can only produce a good harvest under conditions of good air permeability. On dense soils, roots cannot germinate and plants do not have access to nutrients and moisture. The next group of degradation is pathologies of the soil profile and genetic soil horizons. This category includes a variety of negative effects, such as soil removal from ecosystems and general landscape disturbance. What is the essence of this process? The truth is that humanity is expanding at a steady rate, with the population increasing year after year. To accommodate such a large population, we are constantly removing land from nature through urbanization. This equates to nearly 2 billion hectares of diverse soil alienated and excluded from natural and agrosystems worldwide by cities, roads, warehouses, mines, and so on. By next type of degradation is a violation of soil and ecosystem bioenergetic regimes. The soil is at the heart of any natural or agro-ecosystem. The loss of the cover of soil is referred to as devegetation. It causes soil to lose ecological function. Soil loses root biomass as well as valuable mineral and organic substance reservoirs as bioenergy resources. Organic matter loss occurs in agricultural landscapes. The soil loses organic matter through mineralization, and carbon dioxide is diffused into the atmosphere. And this has a significant impact on the climate. The next negative effects include sick soil syndrome, toxicosis, and soil depletion. Crops that are grown in monoculture or minimum crop change may accumulate metabolites, and toxins in the soil. Regarding that, the microbiocenosis is rebuilding. This causes severe plant suppression and a decrease in yield. Soil depletion occurs when nutrients are removed from the biological cycle and not compensated by fertilizers. Deserts and steppes typically have lower than optimum soil moisture level, and plant cultivation further dries them more. Furthermore, the natural acidification process and reduction of atmospheric precipitation are imposed in many territories due to the global warming. Too high a livestock population causes turf disturbance, overcrop action, and structurelessness of the soil surface. FAO data shows the world irrigated land area is about 220 million hectares. However, when irrigation system projects or operation rules are bad, side effects such as secondary salinization and solidification occur. These factors contributed to the demise of the ancient Sumerian civilization. In a hot climate, the sun evaporates water and the salts dissolved in the water remain in the upper layer of the soil. This is a completely anthropogenic effect and that must be eliminated. Unfortunately, we rarely see a full match between soil acidity and plant requirements. Furthermore, incorrect application or physically acidic or alkaline fertilizers can shift the soil solution reactions. Today, long-term targeted programs for the prevention and elimination of soil acidity and alkalinity are needed all over the world. Soil contamination with agrochemicals is also common. Application of fertilizers in such quantities that they become toxic to plant must be avoided by their calculation the plant yield using soil diagnostics and space data. Excessive amount of various pesticides pollute the soil. The pesticides themselves can pass into the harvest, negatively impacting the health of people and livestock. All of the things I mentioned in the previous section were observed directly by farmers. Scientists discovered the causes of this degradation and devised methods to combat them and mitigate their consequences. Thanks to modern laboratory analysis methods, satellite technologies, and modeling methods, scientists have developed such tools that allow agriculture to be named one of the most technically advanced industries. Today's yields are 5 or 10 times higher than ancient yield 100 years ago. This is a significant accomplishment for science. Modeling is the foundation of modern soil science and can be applied in any of its direction. What exactly do we mean by this direction? Digital soil morphometry, for example, is modeling the soil profile and its essential characteristic. It discovers how specific process occur and why, how, and where, for example, moisture moves. Using this approach, we can calculate the reserve or dynamics of soil moisture. Now, we can move on to voxel modeling, the three-dimensional modeling of soil parameters in the entire soil volume. Soil is not a flat surface on which plants grow. It has an average thickness of 1.5 to 2 meters, and crop roots grow throughout this entire volume of soil. We can use voxel modeling for an estimate of where the highest concentration of nutrients is, how deep to apply fertilizer, and so on. It also reveals how nutrient concentration changes in space and how it changes over time. The modeling and mapping of degradation processes come next. Existing empirical models are based on many years of field experiments. At the same time, some theoretical models use the most recent advances in physics and digital elevation model analysis. They can simulate erosion, sediment transport, and soil particle deposition for a wide variety of conditions. Thus, we can calculate the number of the transferred soil particles and their transfer rate, simulate crop types, and measure rain intensity. Other factors influence water erosion processes. The second aspect of studying soil degradation is monitoring water erosion processes. Modeling and satellite monitoring enable us to perform cross-validation and confirm whether erosion is prevented or not. A combination of obtained data provides complete information about the water erosion processes. On this basis, we can develop analytical tools and propose solutions to reduce or eliminate all negative effects. We have the same situation with wind erosion modeling. There is a wide range of models allowing us to analyze all factors and develop the most effective strategy for combating wind erosion of soil. Modeling of soil contamination by industrial or agrochemical pollutants based on the curvature of the topographic surface, specifically the accumulative curvature. These methods provides us with a map of depressions where pollution will accumulate and is more advanced than regular grid sampling for monitoring. The various mathematical models depicted on this slide are used to solve specific problems. For example, both simple interpolation and modern modeling methods can be used to create spatial models of soil organic carbon, nutrition elements, and so on. Furthermore, incorporating satellite data enables detailed analysis of the causes of variation in soil fertility and crop yield. To create predictive soil maps, we analyzed a digital elevation model. Then we select several geomorphological parameters associated with a given soil taxon and use them as predictors. The resulting soil maps are reasonably accurate, even in locations where soil maps were previously unavailable. The last topic I'll discuss is modeling carbon sequestration by soils. Soil is a largest carbon reservoir containing 65% of all carbon storage in the 3-meter layer and nearly 700 gigatons of carbon in the directly cultivable layer. Organic matter mineralization occurs if we do not add enough organic matter to the soil. Thus, carbon is released from the soil and returns to the atmosphere. This contributes to global warming since carbon dioxide is a greenhouse gas. However, modern agricultural practices that accumulate carbon from the atmosphere help to fight climate change. We use technology that allows us to calculate the potential of this sequestration for various land use scenarios for many years ahead. Plants can help us transfer carbon dioxide from the atmosphere to the soil's organic carbon. Modeling these processes allows us to calculate how to soil's tendency to accumulate carbon change as soil cultivation and land use change. Based on this, it is possible to develop an appropriate strategy for a multi-year shift in agricultural land use. Thank you for your attention.
Okay, I'm back here. Thank you, Vasyl, for your presentation.
Not at all.
We're like going to cover the last but not the least like topic of our presentation. This is the role of EOS SAT in precision agriculture and in particular in measuring soil organic carbon. So as you know, 2 weeks ago, yes, 2 weeks ago, we launched our first ever satellite, SpaceX delivery to the Sun synchronized orbit, and it's already there. I think we get, yes. This is just, yeah, so.
Dragonfly Aerospace, EOS Sat-1, separation confirmed.
EOS Sat-1 separation confirmed. This is like honey to my ears. We're expecting to get actually the first imagery. We already get like the radiometry from the satellite. We're connected with that, and we're expecting to get the first imagery at the end of March, April, and probably they're going to be available on the platform this summer already. So here you can see the happy faces of our 200 employees all over USDA, because we've been working on this satellite for 2 years, 2 long years. Let me just remind you a little bit why we decided to launch it and why is this like so important. Yeah, so this is all our team. Okay, let me just do this. Yeah, so as we've been like, first of all, we started with exploring bottlenecks like, oh, sorry guys, I'm struggling with this program a little bit. So we've been exploring the bottlenecks in the food production industry, understanding like what they are lacking. And probably this is going to be better. And we understood that they are lacking quality data, quality and affordable data. The frequency, the only satellite that we have we compared it to the non-commercial and commercial satellites that provide, and the frequency is not enough. Like the size of the fields in Asia, India, and African countries where farming lands is like 80% of them are smallholders that have 1 hectare, 2 hectare fields, but this is like 80% of the production in these countries that they provide. And we understand that we need to provide them with the access to better resolution data where it could, with more pixels on their 1 or 2 hectare field. And also they experience difference with interpreting the data they get, even though like for those who work with NDVI or MSAVI for a long time, like this is green is good, red is bad, but that's not so easy as we can think about that. So that's why we decided to launch our own satellite to cover all those bottlenecks. And once all 7 satellites will be there in the orbit by 2025, we expect to get 1-day revisit, and tasking will be available for specific areas of interest. Resolution that we have, this is multispectral 3-meter resolution and panchromatic 1.5. Will be providing exclusivity for selective partners over selective areas. And also this satellite will be harmonized with Sentinel and Landsat. So kind of if we want to do some analysis or modeling that requires access to the historical data, it will be possible. We can use the data of Landsat and Sentinel. A couple of words, what other things are included in the satellite? So this satellite gonna have around 30 bands, near channel and sphere channel. This is something that will allow us to obtain biophysical parameters like LAI of a par, something that you can use in biophysical modeling. And this is something that will improve the accuracy of yield prediction. for different crops in different areas, and of course the frequency of the data. Yeah, so we'll be able to receive better quality yield prediction results as we use model that considers the satellite data, and every time where we get new imagery, we can incorporate this imagery into the model and get better results. So our yield prediction model is not only based on weather data, but also considers satellite data. And the more frequently we get this data, the better results closer to the harvesting date this model shows. Yes, it's going to be able to combine it with Landsat and Sentinel, as I already mentioned. And this is actually very important. Another, yes. So we're gonna incorporate it into machine learning algorithm that we have here, like for crop classification in particular. So, for example, another challenge that we face in the moment. This is classification of sugarcane in India, because some customers request us to find the areas, because 80% of the sugarcane mills, they belong to smallholders, like 1, 2, 3, 4, 5 hectare mills, and we need some players on the market that want to know the availability of this crop, because India is pretty much, and like Thailand, are pretty much like new and fresh market. So, and we struggle because the resolution that we have at the moment, and the area is very big, so we cannot, using like commercial satellite, it's not that cost efficient. That's why we're struggling. And this is another thing that will allow us to access the availability of crops within those smallholders farms. Let me switch to another slide. Yeah, don't forget about your questions, right? So I'm waiting here while the slide is downloading. Yeah, all the popular baits, NDVI, MSAVI, SAVI, RECI, and DRI, those will be available. And also, Sphere channel will allow us to get irrigation index that will be able to use in biophysical models as well. This is something that will help us also to solve problems and recommend you and give you recommendations on fertilizers and pesticides using and manage the usage of fertilizers and pesticides. And of course, with the better resolution, better frequency, will improve the problem identification and will give you better recommendations on that. So that's pretty it. We're really excited about the launch that happened. We've been working on that for such a long time. And thank you very much for your attention. We'll go to the Q&A session. Here we go. Let me check on the questions that we have in the chat. So my colleague is assisting me in the chat. And in case we do not answer some of your questions, just email them at sales@eosda.com and we'll reply to them there. So somebody else, so I cannot see the name. I like seeing the name, like of people who asking me questions. Let me see. So the first question. A part of EOS data, do you also use drones images in your digital farming? Let me answer that. Not really. At the moment, we don't use the drone imagery inside the platform or inside modeling, because the model for drone imagery requires like a huge calibration. So my answer at the moment, no, but if you have some kind of project or any ideas how to implement it, incorporate it, reach out to us, we can discuss it. Does the order of implementation matter for a soil carbon project? Okay, I'm trying to understand, does the order of implementation matter for a soil carbon? For example, can you meet additionally and access carbon credits if you're already implementing improved practices? Since I know, we're working through partners and we're encouraging our partners to like we're helping our partners to encourage farmers to switch to this new and improved management practices. But from what I know, before entering this project, you need to do soil sampling and kind of provide proofs that how your soil content has changed before the project implementation, before implementation of these practices. But I would recommend you to reach out to some like partner that works with soil carbon credits to consult on that. But since I know like you need to do soil sampling before the project starts. Okay, what we have else here? Okay, Vasyl, I can think this is for you. How can we minimize the loss of organic matter of soils? How can we minimize the loss of organic matter of soils? Bernard is asking you.
Okay, thank you for question. Loss of soil organic matter or dehumidification occurs against the background of a long-term lack of application of mineral and organic fertilizers, as well as erosion processes. If the soil does not get organic material, intensive mineralization of soil organic matter begins. As a result, some of the preserved nutrients in humus become available to plants. There's such a thing as organic matter balance in the soil. To make it without a deficit, in the conditions of the forest steppe of Ukraine, for example, we need on average 8 tons of organic residues or organic fertilizer per 1 hectare. The second way is to prevent soil erosion in any form. I'm finished.
Thank you. Okay, thank you for covering this question. I can see, okay, Rory is writing like soil carbon project is excellent and great use of satellite technology. Congratulations. Thank you, Rory. And Rory is writing that minimize loss of organic matter by keeping soil covered with vegetation and minimizing chemicals. That's what we promote. That's why we are working with AgriProve, and probably will have other partnerships all over the world to encourage farmers use like improved practices and get paid for that. It actually makes a lot of sense, right? Among available soil organic carbon models, which one is the best to estimate soil carbon? I'm not like the scientist here to answer this question. I know that we use like ROS-C model at the moment in combination with satellite imagery with some improvements on our end. So probably it works the best like for the challenge we have at the moment. Like, yeah. What is granulation? What is granulation of satellite analysis? If you could please clarify it, if I got it, if I'm getting this question right, what do you mean by granulation? Or you can reach out to us via email, and our scientists will help you with that if it's like scientific related question. Keen to know if satellite analysis is useful for small farms. Hence, my question about image granulation. Okay, this is like, okay. What is covered by a pixel? Is it dependent on latitude? Small farms have the most to gain from poor soil management. Okay, I understand what you mean by granulation. Yes, actually, that's what I'm talking about. Depending what you mean by small farms. Is it like 1 hectare, 2 hectare? So, for example, for a better understanding, if it's like 1 hectare and you are using Sentinel with 10-meter resolution, it's going to have like 10 pixels per hectare. Sometimes it's not enough for analysis, but still you can get like some picture from there. That's why like 3-meter resolution will give you more pixels per 1 hectare. And then of course, like with the satellite that will launch and the resolution of the imagery that will have like 3-meter resolution, you can use it and get better understanding of your fields. Is it dependent on latitude? No. it's available all over the world. Small farms have the most to gain from power soil management. Actually, yes, because this is like having cover crops for small farms and no tillage practices. That's pretty easy. Do you have any similar projects for farmer company as the one in India? When asking about similar project, do you mean like soil organic carbon measurements, right? Just clarify or like clarify the question. Another question: how can fertilizers harm people and ecosystems? Vasyl, can you cover this question? Like, I'm not really good at fertilizers.
Okay, 1 minute. The excessive amount of fertilizers not only leads to crop growth, but also makes crops toxic to humans and the environment. Everyone perhaps heard about nitrates. Consumption of food rich in nitrates can lead to paralysis of the heart muscle. Keep in mind that vegetable especially accumulative a lot of nitrates. Finally, a large dose of fertilizer can get into neighboring reservoirs and rivers. Excessive concentration of fertilizers in water lead to such a phenomenon as eutrophication. Water is green due to the increased growth of algae. This algae use a very large amount of oxygen from water and fish begin to die. Therefore, improper use of these inputs causes a chain of negative events. I'm finished.
Okay, thank you. Yeah, just from my end, I will add like it's like obvious. Like if you put something into your body that is not actually healthy, right? Or it doesn't matter even if you put food in your body, it has some kind of consequences. The same with the soil. Like if you put fertilizers which are toxic, which are chemical, of course they're harmful. Like okay, do you okay, where am I? Keen to know if satellite analysis is useful for. Okay, we covered this one. Sorry. Do you have any similar project for farmer company as the one in India? Yeah, I asked to clarify one. By using machine learning, it's not necessary to use crop spectral signature. It depends on your challenge. Like specify the challenge here, and probably yeah, not always. Do you currently have partners in Africa on soil testing? Africa. I don't think so. Maybe like because I have many colleagues that work with like country with Rwanda, Nigeria, Tanzania, and other countries in Africa. So maybe they have. But if you have some suggestion, email us. We'll discuss it. We're open for new projects or new suggestions. Do you have a scholarship program for research and education? We have educational program on our website, and actually we provide access to the platform if you can prove that like you're going to use it for educational purposes. So you can find this educational program on our website. My colleague will share the link to that. Will your new satellite cover New Zealand and water resolution? Yes. Like the satellite gonna cover the whole world, like the worldwide coverage, and resolution gonna be multispectral, 3 meter, with ability to downscale it in Panchrome 1.5. For such resolution for images, are you satellite low or medium orbit? It's like sun-synchronized orbit, if this is your question about this. Do your new satellites cover West Africa? Also, are there projects on collecting ground truth data for better machine learning modeling? West Africa. Like, I'm just thinking about geography in my head. Mm, Probably my colleagues that are working with the partnership can cover this better, but at the moment I cannot recall any project where we collect ground truth data there. But if you have some suggestions and you are ready to share some data with that, we're open to talk about like how we can do this. Like probably talk about like projects. So email us at sales@eosda.com and we'll talk about this. Is it possible to command pumps of our farm using directly informations that EOS give as output to command pumps? Okay, it's do you get it right? It's about question about irrigation. Sorry if I'm like asking you questions as well. Um, yeah, could you please clarify the question? What do you mean by command pump so I can answer this? What is the depth of soil analysis in matters? Oh, it's like more than one, it's like 1.5 meters. And then you need to analyze like every layer, every 10 centimeters of the soil, 10, 20 centimeters of the soil. Uh, Project like the one on the sugarcane in India, what you provide services for monitoring the yield? If you're talking about sugarcane in particular, we actually had a similar project providing the harvesting status, harvesting dates of specific mills. And the partner used that in their model for yield projection. So they kind of have their own yield projection. So knowing the dates and the hectares that have been harvested was enough for them to project yield. So it means like we can provide you with reports, like with field ID and the hectareage that has been harvested on this specific field. And you can incorporate this in your model. Or also like we can provide the yield modeling services for sugarcane to predict and project possible yield. All right. And the last question, I think the last one. What's the cheapest way to avoid manifestations of water erosion? Vasyl, I'm experiencing difficulties with this manifestation word.
Okay, one moment. I think the easiest way to avoid the development of water erosion is to use proper crop rotation. This method belongs to the group of organizational and economic measures. Depending on the relief and already existing manifestation of the erosion, various crop rotation are introduced, up to soil protecting ones, which are dominated by perennial grasses. Often this is enough. It's the simplest way. Thank you.
Okay. Oh my God. I'm not a scientist. I think I should have get one like the education. Um, and I can see the last one. You mentioned approximately 3 meter spatial pixel resolution. How much drift impressions is there between images taken on different days? You mean the frequency? Like once the whole constellation is there, it's like 7 satellites. By 2025, we expect to have daily revisit, like daily imagery in some specifics, like selective areas. And in some areas, like 1, 2, 3, from 1 to 3 days. What crop types can you provide yield expectations for onions, potatoes? Like we've been working with 20 crops, most like cereals like wheat, maize, soybean, canola, tobacco, cotton. Those are the best that are showing the best yields, the best accuracy. Actually, sugar beet, like up to 20 crops that we already been working with, that we have already ready-made pipelines for them. And also, like, we have experience working like with others specific. So let me just know what crops you are interested in, and I'll tell you what kind of accuracy we can get there, you should expect, and if we can work with that. You're asking about onions and potatoes specifically. It's a bit sophisticated because like the vegetation that is on the top is not always directly shows you the yield that you can get. So it's like pretty difficult. But also ask for more details via email. I think I covered everything. Yeah. Okay, I think, yeah, that's it. Thank you very much for your attention, for your very interesting questions. We'll send the presentation and this recording afterwards, like in a couple of days. Just check your inbox. If you have questions, suggestions, please like email us at sales@eosda.com. It was pleasure like presenting to you. We're really, thank you for joining us. Take care. Have a good day and night. Bye.